So let's look at some of the evolution of emissions over the Holocene, as we just saw. Also, more importantly, over the modern times. Typically, the time since Industrial Revolution is now referred to as the Anthropocene. The term that was coined by Paul Crutzen, a Nobel laureate who recently passed away, unfortunately. Geologists don't just change the names of geological periods willy-nilly, so they need to go and find geologic confirmation for changing the name from Holocene to Anthropocene in terms of evidences in sediments, rocks, whatever else. Okay. As interesting as that is, looking again at the period after the time we left off here at 10,000 years ago. So from 12,000 years ago to the present, there have been remnant glacial ice temperatures and the Industrial Revolution evidences and so on. This is from a paper which basically tried to correct some of the arguments, or resolve some of the arguments in the reconstruction of the Holocene temperatures. The earlier studies had not been very clear on whether they were looking at seasonal temperature changes or changes in annual maximum temperatures over this time. So putting it all together, that paper referred to here in this article corrects the temperature record for the Holocene. There are many very detailed temperature records shown as well that go into the so-called Holocene optimum, focused on 6,000 kilometers, the medieval warming, or even going back to the Roman period, medieval warming, the Vikings colonizing Greenland, Little Ice Age dominating the European sector in terms of cooling and increased ice cover, and then of course the Industrial Revolution. So you can see here the receding ice continued, and there are other AMOC perturbation kind of events that happened around 80 to 50 years ago. Rising greenhouse gases continued, and then we have this so-called hockey stick shape, which is mostly from temperature. So you can see that the rapid increase since the Industrial Revolution here. So this is the atmospheric CO2, which also has essentially the hockey stick kind of shape from the emission from the Industrial Revolution, which started with coal burning, moved to oil, and then to gas, and now more and more renewables for various purposes. So today we are 2.5 degrees C warmer, 160 ppm higher than 12,000 years ago. The warming that we focus on typically is since the Industrial Revolution, more from 1850 or so, where we have lots of data. So here is the colder and warmer periods, right? The feedback between temperature and CO2 worked over this period as well, going to the last glacial maximum to the present, to about let's say 8,000 years or so, 9,000 years ago or so. And you can see that the slight phase differences and the strong relation between CO2 and temperature holds on this deglacial time scale, where carbon cycle is a positive feedback or unstable. And then we are doing massive perturbations here, and now we need to know whether we will kick in the unstable carbon cycle, or whether carbon cycle will continue to be a stabilizing effect in terms of now taking up all the emissions. So what are the emissions? Not all the emissions, but most of the emissions when we look at the reservoirs in the atmosphere, land, and ocean, right? What are the emissions like? So greenhouse gas emissions by sector, if you look from 1990, I'm just going to focus on this more recent period. There is a reason to do this, because we will see that the cumulative emissions since Industrial Revolution are dominated by the industrialized world, US and Europe, and then later by Japan. But the awareness about global warming jumped up during the 1990s, and since then India and China have become quite a big polluters or CO2 emission economies as well. So all the negotiations tend to focus on this time horizon of 1990. Nonetheless, electricity and heat production dominates the greenhouse gas emissions. This is greenhouse gas emissions, so it is in CO2 equivalent. So we convert methane, nitrous oxide and HFCs and CFCs and so on into CO2 equivalent. There is a way to do it using their global warming potential and so on, which we haven't talked about much here, but I have other podcasts you can look at on that. Okay, transportation continues to grow. Now we are driving more and flying more and more. Manufacturing and construction continues to increase. Agriculture has steadily increased, but not as fast as transportation and electricity and heat. But agriculture also uses electricity for withdrawing waters and spraying fertilizers and other things, processing grains, etc., etc. Land use change and forestry. So deforestation has kind of peaked since about 2015, but there is still a big concern. There are other details about how climate change itself affects forests and forest fires and release of carbon, etc. And there are other here waste, aviation, shipping, etc., etc. CO2 emissions alone, so not in terms of CO2 equivalent, but CO2. Again, electricity and heat, you can see there is a slight difference, but transport, agriculture disappears because agriculture tends to come through methane emissions and land use change, so CO2 equivalent. Manufacturing and construction, buildings, land use change and forestry, industry and other so-called fugitive emissions, etc. Okay, so the main message I will come back to later is that despite the numerous negotiations going on, our emissions continue to increase. Okay, you can see it this way by looking at the CO2 emissions by region. So since 1850, where we have good data, even though the Industrial Revolution started quite a bit earlier, Europe and United States led early on. Here EU27, Europe excluding EU27 and then EU27. And later on, especially since about 1990, China has taken off, India is beginning to increase, and then other countries are adding increasing amounts as well. So you can see there are some flattenings and more rapid increases in economies that are growing. Other Asian countries excluding China and India, and Oceania, which includes Australia and other countries, island countries, and international transport, which is not assigned to any particular country. So you can see here now per year we are emitting a total of 35 to 40 and continuously increasing amounts of gigatons of CO2 or billion tons of CO2. So again, remember CO2 and carbon. You have to be careful about the conversion factor of 3.7 there. Okay, so that's something to keep in mind. Just to add, per capita CO2 emissions, so even though the numbers here are big, China now rivals the US, but in terms of consumption, per capita consumptions are high for US, Canada, Australia and some countries here. Middle East, of course, oil-rich countries, but China is now second after US and then maybe behind Europe overall. But countries like India and many countries in Africa and South America remain very low, the so-called global south, which are developing countries. Their per capita emission can be very low. So US is somewhere in the range of 15 to 20, whereas India is in the range of 2 to 3, and China is in the range of 7 to 8. So these things matter as well. And then there are what are called embedded emissions, where China is manufacturing and exporting, so the emission is happening here but consumption is happening here. So how do we count for that? Right? So cumulative emissions, if you look at, obviously US and Europe dominate. Russia comes out here big, and so does China with the recent contributions. But most of the poor countries haven't contributed that much. As I said, This can be used to argue for compensations, green funds, technology transfers, etc., etc. But right now the focus is really on the emissions since 1990 onwards, where we all became keenly aware that global warming is a direct consequence of our emissions. Before that, we were not so aware, even though there were evidences. Swante Arrhenius said that way back in 1876, I think. Guy Callender had a nice paper in 1937. Wally Broker was saying it in the 70s. CO2 data was showing it already by the 60s, and so on and so forth. Nonetheless, international awareness and debates and agreements started in the 1990s. Okay, so that's a brief background on how much we are emitting, and now we will go into the uptake of carbon by land and ocean and see what we can infer in terms of the stability of the carbon cycle.